Today we are going to learn about essential steps for deploying machine learning models. You will discover how to effectively transform your machine learning projects into production-ready applications and gain the skills to outline and execute a basic deployment workflow.
Welcome to our video on essential steps for deploying machine learning models. In this video, we'll explore the crucial process of deploying machine learning models. Deployment is the bridge that takes your model from a conceptual prototype to a fully functional, production-ready application. Understanding this process is vital because it allows machine learning solutions to operate in real-world environments, making them accessible and useful to end users. However, deployment can be challenging due to issues such as system compatibility, scalability, and performance optimization. Today, we'll take a closer look at each step involved in deploying models, ensuring that by the end, you'll have a comprehensive understanding of how to bring your models to life in practical applications.
The first step in deploying a machine learning model is setting up the deployment environment. This involves defining the system requirements based on your model's needs, such as processing power, memory, and storage capacity. You'll also need to select appropriate hardware that can handle the computational demands of your model, whether it's on-premise servers, cloud services, or edge devices. Ensuring compatibility with your software stack is crucial, as mismatched environments can lead to integration issues. Networking and security are also vital components. Ensure your environment is set up to protect data and maintain privacy. Finally, prepare for scalability by designing an environment that can grow with increasing demand. This step lays the foundation for a smooth and efficient deployment process.
Choosing the right tools and framework is a critical decision in the deployment process. With a plethora of tools available, it's important to evaluate them based on your specific model requirements. Consider factors like the complexity of your model, data handling, and processing needs. Framework compatibility is another key consideration. Ensure that the tools you choose can easily integrate with your current setup and future expansions. It's a balancing act between usability and performance, where sometimes a more user-friendly tool might come with limitations in scalability or customization. Additionally, select tools that offer robust monitoring and maintenance features, as keeping your deployed model running optimally is just as important as the initial deployment.
Before deploying, it's imperative to prepare your model properly. This preparation involves optimizing your model's performance to ensure it runs efficiently in the deployment environment. Compatibility is a priority, so check that your model works seamlessly with the chosen tools and frameworks. Testing with real-world data is crucial. This helps identify how the model performs outside of controlled conditions and allows you to address any discrepancies. Handling potential edge cases is also essential to prevent failures in unexpected scenarios. Finally, document the model specifications thoroughly. This documentation will serve as a reference for troubleshooting and future modifications, ensuring that anyone working with the model has a clear understanding of its capabilities and limitations.
Containerization has revolutionized the way applications are deployed, and Docker is at the forefront of this technology. Using Docker to containerize your machine learning model offers numerous advantages, such as consistency across environments, simplified integration, and scalability. Start by setting up a Docker environment, ensuring your system has Docker installed and configured. Next, create a Docker image of your model, encapsulating all necessary libraries and dependencies. This image serves as a portable unit that can be run on any Docker-supported platform. Testing the Docker container is a critical step to ensure that everything functions as expected. Once verified, deploy your container using orchestration tools like Kubernetes, which manage deployment, scaling, and operations of the containerized applications automatically. This approach not only simplifies deployment but also enhances the reliability and efficiency of your machine learning model in production.
Integrating your machine learning model with cloud services can significantly enhance its scalability and accessibility. Cloud services offer benefits such as reduced infrastructure costs, on-demand resources, and global accessibility. Start by choosing a cloud provider that meets your project needs, whether it's AWS, Google Cloud, or Azure. Each provider offers unique features, so evaluate them based on factors like cost, ease of use, and service offerings. Setting up cloud infrastructure involves configuring virtual machines, storage solutions, and network settings to support your model deployment. Deploying models on the cloud requires understanding the provider's deployment processes and utilizing their tools and services. Ensuring data security and compliance is paramount. Implement encryption, access controls, and regular audits to protect sensitive data. By leveraging cloud services, you can ensure your deployed model is robust, flexible, and capable of handling varying workloads.
Once your machine learning model is deployed, continuous monitoring and maintenance are crucial to ensure its ongoing effectiveness. Monitoring allows you to track the model's performance in real time, identifying any issues or deviations from expected behavior. Set up monitoring tools that provide insights into metrics like response time, accuracy, and resource usage. Analyzing this data helps you understand how your model is performing and where improvements can be made. Implementing feedback loops is an effective way to refine model performance. Use new data and user interactions to continuously update and improve the model. Regular updates and maintenance are necessary to keep up with changes in the data or environment, ensuring your model stays relevant and performs optimally. By prioritizing monitoring and maintenance, you can maximize the life and utility of your deployed machine learning model.
Deployment challenges are inevitable, but understanding and addressing them can greatly enhance the success of your machine learning models. Some common deployment issues include system compatibility problems, scalability limitations, and data integration challenges. To troubleshoot these issues, develop strategies that include thorough testing, comprehensive documentation, and collaborative problem-solving approaches. Ensuring model reliability involves regular testing, updates, and validation against new data. Scalability challenges can be overcome by designing flexible architectures and leveraging cloud resources that allow for dynamic scaling. As technology evolves, adapting to new tools and methodologies is essential. Stay informed about advancements in deployment practices and continuously update your skills. By proactively addressing these challenges, you can ensure a smoother deployment process and a more robust model in production. In conclusion, deploying machine learning models is a multifaceted process that transforms your projects into impactful applications. Today, we covered essential steps such as setting up the deployment environment, choosing the right tools and frameworks, preparing the model, containerization with Docker, and integrating with cloud services. We also discussed the importance of monitoring, maintenance, and addressing common challenges. Each step plays a critical role in ensuring a successful deployment. By following these steps, you've gained valuable skills that can be applied to real-world scenarios. We encourage you to apply this knowledge and continue learning. Explore additional resources and stay updated with the latest trends in machine learning deployment to keep advancing your expertise. Thank you for joining us in this educational journey.